So let's talk about the Pulsar function runtimes. So we mentioned earlier, right? There's different deployment options for Pulsar function. We saw cluster mode and we saw local run. But in cluster mode itself, there are different options as far as where these Pulsar function instances can run. So we'll talk about function instances versus function workers and some of the different runtime options that are available for Pulsar functions. I've alluded to the Kubernetes, and we'll also talk about some of the other ones here as well. But a Pulsar function instance is what's created when you do that create command we saw from the CLI. So you create your artifact, you have your jar file, you say Pulsar functions create, and you give it, the configuration file and your artifact, give it a name like that, and it's going to deploy that information up. It uploads that artifact to Pulsar, and then under the covers, it creates all these different elements executing inside the runtime environment, right? So a collection of consumers, one consumer per input topics you specified. So in the previous example where we had two, there'd be two separate consumers running and configured on each one of those input topics. There's an executor framework that wraps it, again, based on the programming language of your artifact, to make sure that the function gets invoked, and there's a runtime environment for it. And then there's optionally a producer, again, that sends the result of the function to an output topic. This is all the boilerplate code that's created for you automatically and runs inside what we consider a Pulsar function instance. Every instance has all of these things in it. A Pulsar function can have multiple instances. That was the parallelism definition of that. So if you say parallelism of three for individual function, then there will be three separate instances of that, each with their own consumers and producers and execution framework for that, right? So it's not multi-threaded at that level. It's really run as individual instances as well. So this is conceptually sort of how it looks. There's a function instance running here. So you have input topics coming in. There's a consumer dedicated to each input topic that you have specified as the inputs for the function, and they trigger and execute so they'll consume the message, they'll get the message, and then they invoke the code. They will call process, the process method on your function class, and pass in the input message as that input parameter, right? So they pass that in. They also pass in the context, right? So they actually invoke that method here, and that's done in the executor. And again, there's an optional producer method that if the return from that particular function, if there's a return value, it gets passed to the producer, and the producer then produces a message to an output topic. It has a connector to a log topic, as I mentioned before, and it has direct access to Apache BookKeeper, so you can do stateful processing, get state and put state, and all these different options that are available for you are accessed through the function instance. So this is what a function instance is: consumers, producers, and a runtime framework for the Pulsar function source code. Now, function workers are individual components, separate pods running inside Pulsar function itself. They're associated with it to Pulsar. So you have, by default, you have your broker components, right? That's your stateless serving layer. You have Apache BookKeeper bookies. That's your persistent storage layer. You optionally have Pulsar proxies. And this fourth option here is what's called function workers. And they're designed explicitly for the running and executing individual Pulsar function instances, right? So within these function workers, each function can be executed as either a thread or a process, depending on the selected function runtime environment that's been specified in the function worker.yaml file that we talked about earlier, where you can say, I want a pip installation or things like that. Each function worker is configurable, and you can specify the runtime environment there. Alternatively, if you have a Kubernetes cluster, then the functions can be spawned as stateful sets, individual pods within Kubernetes, instead of running inside function workers. So there's different options as far as deployment runtimes: threads, processes, or Kubernetes pods. So again, this is showing you each individual Pulsar function worker and what exists inside of there. So again, it's a logical component that monitors and orchestrates and executes an individual function in a cluster mode deployment for Pulsar functions. The function workers, and there could be many, form a cluster. There could be a cluster of these worker nodes. And the workflow is kind of shown here, so we've highlighted here. So the user interacts with the REST server using the Pulsar admin CLI and says, hey, I want to execute a function instance, create function. That's what we saw in the deploying section, right? You have your artifact, you say deploy it, you specify your config file, and you give it the artifact, and you call the REST server with that. The REST server responds to the request and passes, takes that information, says, okay, I got it, and passes this information onto the function metadata manager. And this metadata manager writes the request and updates the function metadata to the topic. So this, again, we store all this information. This is your configuration information. That's why it has to be uniquely identified as a tenant and namespace. Each function is associated with that because this is stored by name. It creates a fully qualified name for each function. We put it in this topic, and that's its configuration that's stored there. Once it's persisted, it returns back. And the Pulsar manager reads those updates. Next, the scheduler comes along and says, okay, I have a Pulsar function. It's supposed to be running. It's going to write the assignment updates. It's going to basically figure out where to assign this function to run. It looks at this Pulsar function pool. It does some scheduling and says, okay, I got to figure out where I'm going to run this Pulsar function instance based on its resource requirements. So that's what the scheduler manager does. Once it picks a function worker to run the function instance or instances, it's called an assignment, and it writes that assignment to an assignment topic to track where these functions are running. So it says, okay, I'm going to run it here, allocates resources basically. And then the function runtime manager listens to this topic and reads this assignment update. So we get a message that says, okay, there's an update. I've added a new function worker. I've deleted it, something like that. Again, you can do a delete, comes through here, and you delete a topic and it gets removed from the assignment. So either way, it's either I'm adding it, I'm scaling up the number of instances, or I'm creating a new one from start. This function runtime manager gets these updates, keeps an internal state of all this information, and then it's responsible for basically materializing the new assignment and starting or stopping the execution of the function instances. So it takes the request to assignment and makes it reality. It creates the function instances, instantiates them at this point based on which function workers that have been assigned to it, spins up the runtime environment, right? And that's it. Then everything up and running, everything goes well. Then the membership manager, it's the last part of this particular sequence, requests the coordination topic to elect the lead worker, and all the workers subscribe to the coordination topic. And the active worker becomes the lead and performs the assignment, guaranteeing only one active consumer for this particular topic at any point in time. So again, there's a coordination mechanism done there to make sure that everything that reads updates from the coordination topic to make sure that that if, for example, a function instance dies, it has to be run somewhere else. This coordination is handled here, and this membership manager tracks the lifetime of it after it's been set up and run and assigned somewhere. The membership manager is responsible for running the rest of all the function instance runtime environment, keeping them up and running. And again, here the function instances are deployed across multiple function workers. So this is the entire execution framework, and shows you the difference between the Pulsar function workers, which is the coordination and the scheduling system for Pulsar functions running in these individual nodes called Pulsar function workers, and the function instances just get deployed across all of those. So again, as I mentioned, Pulsar function instances are invoked inside of runtime, and any number of these can be running in parallel. So just to summarize again, there's a different trade-offs between each one of these. So thread mode is one. It can run inside the same JVM as the function worker. Again, this is not recommended for production. This is also available in brokers. We used to be able to run it in brokers. I don't think that's supported anymore. Another option is if you want to run them as processes. Each function runs as a separate process on the function worker machines themselves, and multiple function workers scale out across. So each instance would be its own process. So I have 5 parallel instances of the same function. Each would be its own process running there as well. And as we mentioned before, Kubernetes function runs as a pod on the Kubernetes cluster. It's wrapped in a stateful set to say I want one instance of this running. So this automatically handles failures. If the function instance were to crash, Kubernetes takes care of making sure that it gets a pod gets recreated and started for that. It also allows you for easily scaling out. And the function worker coordinates with Kubernetes to do the assignment on that particular process as well. So let's walk through the function deployment lifecycle steps when you do a deployment. Right. So as I mentioned already, you can either run a separate cluster, just access Pulsar, or they can run in the same process as the broker. Both have a lot of utility mentioned here. So again, the function worker can run either as function workers or inside the same broker as a thread. These are your different options. So a function gets created on a function worker and is initialized. Then the function API starts a consumer or consumers on the topic and starts feeding the function. Again, it creates a consumer. It calls that execute, calls the process method on every time a new message comes in, passing in that individual message. It also starts up a producer API if one's defined as an output topic. And then every time a return value, again, if the Pulsar function method does a return, then all these values are captured and published automatically to the output topic as well. And that could be on a different broker. This is just showing you I could be consuming from this broker and publishing to this broker as well.